All right, so on letter C, it says, for what time greater than 300 are there no people on the escalator? Okay, so on letter C, you are going to say that we're going to do for t greater than 300, what's the starting value? Do we have a starting value? Well, we know we're starting at 300 seconds. Okay, so for this one, I'm going to do 300. So starting value plus net change. So this is for letter C. Okay, so the starting value here is going to be, we're starting at t equals 300 as our starting time, plus the net change. So if we're losing, it's a constant rate of 0.7 persons per second is what we're losing. So what you're going to do is take the answer to part B, and then divide that by 0.7. So like, for example, let's say there were, I don't know, part B, at 300 seconds, let's say there were 70 people, and you're losing 0.7 every second. So you would do 70 divided by 0.7, and that would tell you you're going to be losing 100 people over that time period. So here you don't actually have to do an integral to find the net change, because the change is based off of a rate of change that's constant. So, I mean, you could base it off of an integral if you wanted to, but I would just, rather than doing that, I would just say if there's 0.7 people leaving every second, I would take the number of people at t equals 300. So that's where we're doing it, starting at t equals 300. And from there, you're just dividing it by 0.7 to figure out the total number of people that are, looks like that are leaving to get down to, or let's see. Yeah, until, if you're using, after 300, you keep losing people until you get to a certain time. And after so many seconds, you have no people anymore, because you're losing 0.7 people every second on average. Is that okay for letter C? Okay. And again, I said this at the very beginning today. Even if you don't know the answer to write B, just write down an answer. You could say 10, and then just use that answer on part C. You can still get full credit. So they are looking at your work. The work is very, very important for that, for free response questions.
Why do you divide it by 0.7?
So I gave an example earlier. Let's say you had 70 people. Let's say for the answer B, let's just pretend the answer was 70. So if you're losing, of those 70 people that are on the escalator after 300 seconds, you're losing 0.7 of them every second. So if you want to know how long it's going to take you, so it's, so you're losing people every second. So if you want to know how many seconds it's going to take, you would do 70 divided by negative 0.7. So that would give you negative 100. So that means it would take you 100 seconds to lose 70 people. Does that make sense?
I get it now.
Okay. It's like miles per hour. You just do or if you want to think of it like distance equals rate times time, you could say the rate is equal to distance over time. That's why you're dividing. So we're talking about the rate here. So the rate would be dp over dt. So you would do a number divided by a different number. Okay, anything else on number 1? Okay, so we're gonna go to number 2. Number 2, the infamous plankton problem. This one went viral. Okay, so questions on number 2.
Letter C.
Letter C. Okay, so on letter C, so on letter C, it's asking about why the plankton cells in the column is less than or equal to 2,000 million. Okay, so letter C, I'm going to say million. Equals starting value plus net change. Okay, so the starting value would again be the answer to part B. So part B, do I have that? Read that. So the starting value, we're starting at 30, which is the answer to part B. So the answer to part B, I'm gonna say it's about 165 plus the net change. So the net change is gonna be the integral from 30 to infinity of f of h times 3 dh, because there's 3 square meters. So 3 dh. And we know that f of h is smaller than u of h. So I can say that this needs to be less than, or I should say less than or equal to 60. Five h times 3 h. Okay, and then this is going to equal plus this whole, I can substitute with 105. I pull out the 3. So first I'm going to pull out the 3 in front of the integral. And whatever I have left is 105. So this is good. At 1675, 1675. So when you figure out what this is going to be 1990 point, I'll just say 1990 approximately, because we had to round 1675. Okay, and then it's saying show that it's less than 2,000. So we just said the millions of cells. This number is less than 2,000, so we just proved it. Almost everyone bombed this question. I remember this question from 2018. It wasn't just our school. It was worldwide. It was a pretty evil one. All right, so other questions on number 2. We're okay with the plankton? Okay. Let's go to number 3. I told you every year, I know it's going to be a little different this year, but I don't expect too many major surprises. Maybe there will be something like the plankton, but for the most part, I'm guessing it'll be stuff that's similar to old FRQ questions. So number 3 has always been interpreting a graph using a function defined as an integral. Okay, so questions on number 3.
Can you explain D?
D, yeah, let's look at D. Okay, so on letter D, it's asking about an inflection point. So that would be a change in concavity. Okay, so where does the concavity change? So looking at the graph, it's referring to the graph of F. But be careful here because it's giving you the graph of G. So these are the things you need to pay attention to. So we're given the graph of G. It's asking about the graph of F. So you have to find a relationship between F and G. So what do I do here? So well, there should be something that tells how they are connected. The graph G. Okay, so here it says the graph of the continuous function G is the derivative of F. So I can make a little note to myself here. So G of X equals F prime of X. So we're being asked about, let's see, find the X coordinate of the inflection point of F. Okay, so if I take, that means I want to know where the second derivative is 0. So that means I can take the derivative of both sides here. So that means G prime of X equals F double prime of X. And equal okay, I lost my train of thought for a second. Let's see. So F prime of X. So the derivative, so the graph of F, it's asking about F. So the second derivative is 0. So I would say F double prime has to do with the inflection point equals g prime of x when, or equals 0, when g of x changes from increasing to decreasing or decreasing to increasing. So occur. That looks like it's happening here. So it looks like at x equals 4, the graph is going from decreasing and then it changes to increasing. So that would be the only point where it changes from increasing to decreasing or decreasing to increasing, using our definition of an inflection point. So that would be at x equals 4 is your answer. Make sure you give a reason for your answer, because it's going to be a 2-point question. 1 point is to say x equals 4, and another point is to give a reason. If it doesn't say give a reason, you don't have to. So that's why reading the directions are so important. Let me erase this little stray mark here. So I'm focused on, so backtrack for a second. If it's talking about the graph of f, I'm thinking about the second derivative of f, which is the same as the first derivative of g. So where this changes from increasing to decreasing, I have an inflection point. So other questions on number 3. Okay, so let's clear this out. Number 4. So any questions on number 4? So we're good on 4. Okay, hopefully that's a good sign that you guys are getting, I know you're going to have questions as you go through these, but hopefully you've been able to get a lot of them answered before the Zoom session. That way we can go through more problems on different years. Okay, so I'm going to switch then. So last call, we're good on 4. Okay, so number 5 should be skipped if it's polar. And number 6. Questions on number 6?
Can you use 6C?
6C, absolutely. Let's look at 6C. I think I had you skip 6C, right? Can someone confirm that?
Yes, skip 6C.
Okay, because I know there's several topics and series you need to know, but air bounds would not be one of them. So you don't have to worry about Lagrange error or alternating series error or anything like that. So just for time's sake, I try to focus on the concepts that are.
Can you still do A, please?
Yeah, let's look at 6A. Okay, so for 6A, let's see here. So we have a Maclaurin series for ln of 1 plus x. It's given to us. Okay, so right here, what is it asking for? The first 4 non-zero terms. Okay, so I am going to first step change every x to an x over 3. So I'm going to say ln of 1 plus x over 3 equals, so it's going to be minus, and I have x over 3 squared over 2 plus x over 3 cubed over 3 minus x over 3 to the 4th over 4. So you have two options for the general term. You could either plug it in now, or you can find a pattern at the end. I don't know, one could be easier than the other. It just depends on what you're most comfortable with. I kind of ran out of room, so I'll probably do it at the end. Okay, so here can't forget about this x here. So the last step is I'm gonna multiply both sides by x to make it look like the function it's asking me to find. So this is gonna equal, when I distribute the x, it's gonna be x squared over 3 minus, if you want to see a pattern, I guess you could put this over 1. Then you have x cubed over, I'm distributing the x to all of these terms, so it's x cubed over 9 over 2 plus, and then when I distribute the x to the third term, it's going to be x to the 4th over 3 cubed, which is 27 over 3. And lastly, I have x to the 4th over 4. And if you want to, you could just say x, I still don't have room. I was trying to give myself room. I need to come down here. So it's going to be x to the n plus 1. If we're starting with n equals 1, then n equals 2, n equals 3, n equals 4. Now it's x to the n plus 1 over, looks like 3 to the n divided by n, alternating, so I'm going to times this by negative 1 to the n. Will that do it? So if n is 1, doesn't matter. So when I do minus 1, when I plug 1 in, that'll make it even, or 3 minus 1, or 5 minus 1, or 7 minus 1. You could simplify this, but if you left it like this, this would be fine. How'd they rate it? Times, yeah, you can times the top and the bottom by 1 over n. So any questions on A? All right, anything else on number 6? All right, let's see what we can do for 2017. I know it's a lot, but this is really important. These first 3, like I said, it doesn't get any bigger than this. 2019, 2018, and 2017. And these are all, any small changes were done, like I said, in 2016. So all of them are reflected on these. There wasn't anything made. That's why studying tests as far back as you can go, calc doesn't change that much. Just tiny changes out 1998 and then 2016 were the best ones. Okay, so 2017 now. We're actually doing pretty good. We got through that quickly. I'm kind of thinking as we go on, there will even be fewer questions because I think you guys are gonna get really good at these if you're committing the effort. Okay, so questions on number 1.
Can you do D, please?
D, yeah, let's look at D. Okay, so on D, we know the height is 5. It's increasing at a rate. So let's just write out what we know. That's a good idea for these. Don't have to worry about the units till the end. So H is 5. It says the height is increasing. So dH over dt equal. It says it's, and it says find the rate at which the volume of dt are unknown. So that's how I would start the problem personally. State what is given and then state what is needed. Okay, so right here, I'm going to say that dV over dt equals, I can write this because it has a third variable. I don't think they give you one like this because it's kind of similar to a parametric, but just in case, probably good to look at. So dV over dH, it's not technically parametric, even though it's based on a third variable. So dV over dH over dt over dH. So you can also write this as dV over dH times by the result what's on the bottom rather than dividing. So times dH over dt. Okay, so I want to know what dV over dt is when h equals 5. So this is going to equal, so dV over dH, colors here. So if I want to find dV over dH, let's read this off of volume height is changed. So using this formula right here, because that's what this is. The area, when you're taking a bunch of cross sections, that creates a volume, and it's based off of h. So you need to recognize that what you're finding on C is how the volume is changing as the height is changing. So you can plug 5 into h in here, and that's going to give you it's probably better not to answer. It's hard to write on here. So, but you would do that. And then lastly, you are given h over dt. So you plug that in right here. And then your final answer is going to, here you do need units, especially if it says it. I don't have the, or do I have this? I probably have the solution key somewhere. I'm guessing you probably have certain ones. So make sure you don't want to do all this work and then not get the point for writing the units. So 1.694. If it's volume, that means so it's 194. I'll write it up here just in case you can't see it. 0.694. This is going to be cubic feet per minute. Right here it says foot per minute. So for volume, we are in cubic feet per minute. Just habit, read the problem, make sure the units, write it down or highlight it, underline it while you're taking. Well, I don't know how it's going to work on a computer, but make a note to yourself somehow, include units so you don't forget.
I still don't understand the dv over dh part.
Okay, so for letter C, you're finding the area of cross section. So when you take cross sections, you have a two-dimensional shape. You're cutting that shape. I don't know exactly what this looks like. Just making that. And you have a bunch of horizontal cross sections here. So you're in the graph. So it's like you're coming off. That creates a volume, and it's in terms of H. So this is based on at 5, what was it, at 5 feet for the height. That's going to give you the volume the moment the height is 5 feet. So let's see. That's when you take the, when you take the, or what do we have? The derivative of the volume. Let's see here. So this is the area in square feet of the horizontal cross sections. So as you look at how the volume is changing, is the height changing at 5 feet, that will give you your d over dt, but you have to know that on letter D, you're creating a bunch of things that makes it a volume in terms. So that might be the hardest thing you have to do on number 1 is recognize that f of 5 is the same as dv over dt at h equals. I have the key here anywhere. Okay, so yeah, the volume, let me explain it a little better. So the volume is the integral from 0 to 10 of f of h dh. It would have probably helped if I did b first. It's going to get you back to, so this is the volume. So v would equal this. So then when you take the derivative with respect to h of both sides, that just leaves you with f of, well, you ignore the 0 and the 10 because we're not doing over an interval. We're doing it at a point in time. But when you take the derivative of the function, it gets you back to the function. That ends up being dv over, it's hard to read that, but if you have d of dh, if you're taking that of v, that gives you the dv over dh. So I don't know if that helped any, but when you're taking the derivative of an integral, they cancel each other out to get you back to f. So sometimes it does help if you do like part B before part C, like this would be one of those examples, or part C before part D. All right, so any other questions on number 1? Okay, moving on. We only have 20 minutes, so you guys are doing good. It feels like a lot, but it's only, hopefully we can just make it over here. All right, so I skipped 2. It was polar. So questions on number 3.
A.
Let's look at A. Okay, if you want to find f of -6 and f of 5, so this is the 5th time I've done this today, starting plus net change. So if you're writing on paper, you can spell it out. I'm just abbreviating. So final value equals starting value. So SV is starting value plus n net change. Maybe I'll just use nouns, so I don't have to write out. So final value equals starting value plus net change. So find f of 6. This is the final value. If you want to find the starting value, negative gives us a starting point. So it's 7. I'll just put f of -2 for now. Plus -2, and then we're finishing it next. Again, starting at -2, integrate the function from -2 to -6. Derivative. So we have to take the integral of that. So this is going to equal 7. If you want to find the integral from -2 to -6, you find the area. So to do that, using the graph of from -2 to -6, we're going from left, it's going to make the area negative. So I'm going to going from right to left, from -2 and then going all the way to -6. Then you find the area of this triangle, half of base times height. So half of 4 times 2. So the base is 4, the height is 2. So you do half of base times height. That's going to give 4. That gives you your final value. Start going from -2 to -6. And then for part B, I'm going to do the same thing using the same formula at the top. F of 5 now is the start or the final value. This is going to be the starting value plus f of 7, that hasn't changed. And now that I want to find, first of all, I know that this area right here is 7, so I don't have to find it again. Or, I'm sorry, not 7, it's -4. Does that help me? Never mind, that doesn't help. Okay, this one I'm going to find this area and this area. I'll put it into 2 parts. -2 to 2, that's half a circle. So doing a little scratch work off to the side, the area of a circle is pi r squared, but since we're doing sorry about that technical difficulty again. So we're on number 3. Hopefully we're okay. I see
I'm fine with the rest of it, so you can go on.
Any
have a
questions on
question.
number? I think you guys,
On that part.
yeah.
Why
Go
was
ahead.
why was for f of -6, why was it -2 to -6, like the bound?
Okay, so why it's -2 to -6? Use -2 because that is a starting point. And then it told me to get f of -6, so I use that as a final value for. And I finish here. And the net change is going to be how much it changed from -2 to -6. So that's going to be the integral, the application of integral. Right where I stop. Based on what information I need. That's why I did the integral from -2 to -6. Is that okay?
Yeah, I got it. Thank you.
Okay. So anything else on number 3? Okay. One of these days I'll do a second extra credit at the end. People stick around. One of these days. Okay. I know most of you are self-motivated, so that's good. I don't know, they could have a good reason they had to leave. I just noticed that several people left. Okay. So
It's because we have a
going
physics test
to
right after
number.
this.
You have a physics test?
Yeah, Shayna's making us
Dana?
take a physics test over Zoom.
Yeah, 12:30.
How does he do the test?
We have no idea.
Okay.
He has not told us at all.
It's just an online test then? I
Yeah.
guess it has to be. Okay, interesting. All right, so questions on number 4. Or did I skip 3? No, we did 3. Okay, so I guess everyone's good on 3. All right, so number 4.
B.
Say again.
B.
Or B. That's like a. Okay, so on 4B, we need to zoom in because it is Zoom University. Okay, so 4B, so 4B, I'm gonna be able to see the problem, but make sure it's not too small. Okay, so on B, it's asking for the second derivative. So right here, I'm gonna say the second derivative equals on the right side be the derivative of this, which is just -1/4 dH over dt. So this is going to be -1/4. So we saw this on 2019 where you have to plug the derivative back in when you're finding the derivative. So we did this first semester, if you remember. Time parentheses h minus 27. And then read the question again. Determine if your answer to part A, which I don't know, is an underestimate or an overestimate at t equals 3. Okay, so we know that it's greater than 27 degrees. Second derivative has to be positive for t greater than 0. Okay, so here, part A. Okay, so part A, I'm gonna write the answer for part A here since I need, so I have y equals negative 16t plus d1. So if you take the second derivative of this, it's going to be, okay, so let me draw a graph. Appears to be concave up. So if it's concave up, that means if you were to find this line, coordinate of the tangent line is always going to be underneath. So that's what's going to make it an underestimate. Okay, it tells you that it's bigger than 27. So that's how I know it. Anything you plug in for h here, a number that's bigger than 27. Is this expression positive? There's a little lag right now. You plug in a number bigger than 27, it's going to make this positive. That's how I know it's concave up, because I just showed the second derivative is positive since h has to be bigger than 27 degrees. And if it's concave up, your linear approximation is going to be because the line is always below the graph if it's concave. So that's your answer here. So if you call this graph f of x and you call the approximation L of x for linearization, it's because f of x is going to be greater than the y-coordinate, bigger than the y-coordinate on the L graph. Anywhere near the point of tangency. So I probably have time for one more question. I'll try to pick up where we left off next time, because I do want, especially these recent ones, I want to make sure to go over all your questions. But I could probably do one more right now. So anything else, or any questions on number 4? Okay, maybe I can do one from number, well, so I guess that's it for 4, because we didn't skip 5 for 6, huh? These are probably good ones to look at, and I don't want to rush through them. Okay, I guess we can wrap it up. I still have a few minutes left, but so yeah, we'll meet again a week from today on Tuesday. So what it'll be due on Tuesday is 2016, 15, and 14, and then I'll start off just finishing up 2017 to make sure we can get through all of these questions. So keep using the resources available to you after you try the problems on your own. Like I said, there are great YouTube videos. Just YouTube like FRQ, AP Calculus BC question 5, and I'm sure stuff will come up for 2017 or something like that. So you can probably get a lot of questions answered that way. Please don't wait till the last minute to do these. You want to have time to kind of digest them, think them through. And also AP Calculus, speaking about procrastinating, you don't want to wait till like a week before to really get serious about studying. It needs to start now. And if it does start now, there's no reason very well on this AP exam coming up on May 12th. So less than a month away, hard to believe. So any other just general questions before we wrap it up?